Assalamualaikum and a very good afternoon. So, how are you feeling today, guys? Are you okay? So, you are now at home, enjoying your time with your families, and preparing yourself for Hari Raya celebrations. Okay. However, please don't forget to to take care of yourself. Okay. Make sure you are safe. Don't eat too much, and don't play merchant or bunga api. Okay. Okay, so we will continue back our class, okay, for introduction to polymers, okay, and then we are still in the same subtopic, which is the polymer families. Okay, all right. So basically, previously we already did learn about what consists under the polymer families. Okay, usually under polymer family we can categorize it according its type, where we have thermoplastic and we also have thermoset followed by elastomer or rubber. Okay, previous week we already learned about the thermoplastic families, and for today, okay, we will go deeper or see what is thermoset. Okay, so thermoset is the molecule of thermosetting plastic which are heavily cross-linked together. So you guys need to understand the difference between thermoplastic and thermoset. Okay, thermoplastic itself doesn't have any cross-link. However, thermoplastic doesn't have any cross-link. However, for thermoset materials or thermoset polymers, okay, they have cross-link. Okay, due to this cross-link, they are form a rigid molecular structure. Although they are softened when heated at the first time, which allow them to be shaped, then they become permanently stiff and solid and cannot be reshaped. So this is the significant or the unique characteristic of thermoset, okay, compared to thermoplastic. Thermoset remain rigid and non-flexible even at high temperatures, such as polyester, resin, and ura-formaldehyde are example of thermosetting plastic. So if you see here, okay, this is a structure of thermoset. Okay, so the thermoset are being cross-linked. Okay, and then the unique characteristic of thermoset itself, okay, when it at the first time when heated, it will be soft, okay, so that it can form into the desirable shape, and then once it cool, okay, it will be permanently hardened. Okay, again, if you heated the permanently hardened, okay, materials, it will not become soft anymore. Okay, this is the different characteristic compared to the thermoplastic. Okay, so thermoset itself is a material that becomes solid when heated and may be heated and formed one time only. So it is not a reversible process like the thermoplastic. And then it does not flow when it is heated. Okay, it is a irreversible process. Okay, means that once it become cross-linked, it will not become uncross-linked again. Okay, and then the cross-link form between change by covalent bonds. Okay, so this is what we learned previously. Okay, what is the covalent bond and what is ionic bond? Okay, and then bond prevent the chain moving relative to each other. So I already explained to you guys how the bonds works. Okay, so that the chain will not be moving. Okay, and then another one is only heating to excessive temperature will cause severance of the cross-linking bond and polymer to degrade. So once, okay, this thermoset material had become hardened, okay, or it already cured, if you heated the material again, okay, it will not become softened, but it will started to degrade. Okay, so this is example of thermoplastic and thermoset. So according to the thermoplastic material, when heated, it will melted. However, thermoset, okay, the pure material of thermoset, okay, when you heated it, it will not melt. But however, due to the increasing of temperature, okay, and time exposed to the material, it will started to degrade. This is difference between thermoplastic and thermoset. Okay, and then for thermosetting resin are characterized by a cross-linking reaction, which lead to the formation of a 3D network structure. The greatest advantage of thermoset resin is that they are processed from a low molecular weight compound, unlike the high molecular weight macromolecules in the case of thermoplastic. This is why thermoset-based products can be molded, okay, in general at much lower temperature and pressure compared to the thermoplastic. Okay, so thermoset material, first of all, it is harder, it is stronger, and it is more brittle compared to the thermoplastic. And it have a better dimensional stability. What is the meaning of dimensional stability? Okay, so the dimension or the dimensional stability is, okay, how the product takes shape. Okay, this is due to that, okay, the cross-linking inside the thermoset. It hold the change together and it difficult to move. Okay, that's why it will have a better dimensional stability. This is due to the covalent bonding. Okay, and then thermoset itself cannot be recycled, it do not melt, are usable at high temperature than thermoplastic. Okay, what's the meaning of are usable at higher temperature than thermoplastic? When we use thermoplastic, when exposed to high temperature, it will started to melt. But okay, thermoset is difficult to melt. It's not difficult to melt. It cannot melt. Okay, when exposed to temperature once it is crossing. So when re-expose this material to temperature again or high temperature, it will started to degrade. So it is more usable at higher temperature compared to thermoplastic. And thermoset itself is more chemically inert. Okay, and then this is the most of the cross-link and network polymers, including vulcanized rubbers, epoxies, phenolic, polyester resin, urea resin, formaldehyde-based resin. These are examples. Okay, so this is some example of resin or thermoset resin. Okay, and their precursor. Okay, so phenolic resin. Okay, phenolic resin. Okay, the precursor is phenol and formaldehyde. So it is mostly used as a wood additive, molding compounds, foundry binders, laminate molding, electrical laminates, aviation coating, casting, and fiber composite for household appliance, automotive, aircraft construction and accessories, electrical and lighting industry. Unsaturated polyester. Okay, the precursor is carboxylic, carboxylic acid, diols, and reactive diluents, okay, such as styrene. So the application is for surface coating, fiber composite for mechanical equipment and building, construction, electrical and lighting industry. Epoxy, okay, epichlorine and biphenyls, okay. The application is for engineering adhesive, paint and surface coating, electrical laminates, fiber composite for automotive, marine construction, and aerospace appliance. Okay, and then okay, we also have vinyl ester, melamine, urea, furans, and then polyurethane, polyamide, calcinate ester, bismelamide. Okay, so this is example of thermoset, and I believe that you can read and go through my lecture after this. I will upload inside the e-learning platform. Okay, and then what is thermoset and what is thermoplastic? Okay, what is the difference between these two? Okay, and then what is the advantages of using thermoplastic or thermoset? Okay, first of all, okay, thermoplastic itself, okay, we can see that it has a very weak bond chain, okay, because, okay, there's no cross-linking between this bond, between the change. That's why when heated, okay, it's easily to be melted. And it can be repeated heated, okay, and it will repeat the melt process. Okay, and then due to this ability of thermoplastic itself, which can be reheat and melt, it will be easy to be reprocessed, and it is recyclable. So this is the meaning of recyclable, because the plastic can be reheat and remade and reshaped. So it can be reused. Okay. However, for thermosetting plastic, okay, it has a very strong bonds between the chains, because there is a cross-linking. Okay, and then there are covalent bonds, okay, among the chains. Okay, and then when burnt, okay, or exposed to high heat, it will not melt it, but it will start to degrade or burning. Okay, this is why, because the crosslink cannot be uncured or uncrosslink, it is not difficult to, it's difficult to recycle them, and it's not suitable to be recycled. Okay, and then thermosetting polymer are a pre-polymer in a soft, solid, or viscous state that change irreversible into a infusible, insoluble polymers network by curing. Curing can be induced by the action of heat or suitable radiation, or both. A pure thermosetting polymer is called a thermoset. A thermoplastic or thermosoftening plastic, okay, or else thermoplastic we also can or call it as a thermosoftening plastic, is a polymer that become pliable or malleable above a specific temperature and returns to a solid state upon cooling. Most thermoplastic have a high molecular weight. So you guys know what is the specific temperature, whether it's a TM or TG, and it returns to a solid state upon cooling. This is the unique characteristic of thermoplastic. Okay, so thermoplastic, when heated, it will be melted. Okay. However, okay, for thermoset, when you heat, okay, it will start to degrade because they have cross-linking. Okay, the cross-link hold the chain together and it cannot melt or flow. Okay, the chain cannot move easily when heated. Okay, this is also I already explained during the class how the chain can be how it started to melt, okay, or how the chain, the action of the chain contribute to the melting. Okay, last is about the elastomer. Okay, so let's see what is the definition of elastomer. Elastomer are rubbery polymer that can be stretched easily to several times their unstretched length, and which rapidly return to its original dimension when applied stress is released. So it's just an imagine of your rubber band. Okay, elastomer derived from two terms, elastic and mer. So you know what is the meaning of elastic, and you also know what is the meaning of MERS. Okay, and then from the American Society of Testing and Material, ASTM, elastomer, a polymeric material which at room temperature can be stretched to at least twice its original length, and upon immediate release of the stress will return quickly to approximately its original length. The rubber bands and other elastic are made from these elastomers. Okay, there are three types, okay? Dying elastomer, non-dying elastomer, and thermoplastic elastomer. Okay? So, example of dying elastomer are polybutadiene, polyisoprene, and polychloroprene. Non-dying elastomer are polyisobutene, polysiloxane, silicone rubber, and then polyurethane, fluoroelastomer. And then you also know what is thermoplastic elastomer. It's a combination of thermoplastic and elastomer. For example, SBS elastomer, olefinic elastomer, and copolyester. This is example. Okay, so when you can see that this is why we tend to have thermoplastic elastomer and thermoset elastomer. Okay, so the properties, okay, of the materials, okay, TPE or TSE, okay, first of all, we have one side of the material is likely thermoplastic or thermoset, and another is elastomer, which can be stretchable. Okay, it can be stretchable. Okay, so elastomer, the characteristic of elastomer, they have a very high elongation and flexibility. Okay, it is difficult to break, okay, because of the stretchable of the materials. And then it can be classified into thermoplastic elastomer and thermoset elastomer. The difference between these two is that, okay, thermoset elastomer is not melted when heated, and thermoplastic elastomer, they are melted when heated. It still have the characteristic of the thermoset and thermoplastic. And then this is a comparison between the thermoplastic elastomer and thermoset elastomer. Okay, we can see that. Okay, for the thermoplastic stoma, it is easily recyclable. It is easy for compounding, easy for molding, and over molding. Meanwhile, for thermoset rubber, okay, it will have a very high resistance, thermal stability, and set resistance. Okay, and then the characteristic of the stoma itself has high in resistance to chemical and corrosive environment, relatively low softening temperature, non-crystalline in structure, non-conductors of electricity, and are relatively low heat conductors, exhibit viscoelastic behavior generally to a greater extent than plastic, oxidize or age, causing deterioration and changes in its properties. So this is characteristic of elastoma. Okay, and then this is some example or application of elastoma. Okay, you can see that it's rubber bills, okay, making tire, your wetsuit, your rubber boots, okay, the shoe soles, okay, and mats. Okay, that's all. Okay, here is the attendance for this lecture. Okay, this lecture will be carried out as online and will be available starting from today until 21st April at 5 p.m. After that, this lecture will not be available. So please, okay, complete the lecture before the due date. Okay, you can scan and fill up the attendance. Okay, and then you also can check the attendance afterwards. Thank you. And I wish you all, okay, Selamat Hari Raya. Maaf Zahir dan Batin. Okay, thank you. Assalamualaikum.